Hello, and today I'm going to be talking about storing raw data for permanent use so that when you close the program, you can still access that data when you reopen the program. You could use like a database or a JSON file or something like that, or an INI file, but there's a much simpler way to do it with raw data in C, and it's kind of simpler, and it might work for your use case. So I want to make a directory dat files. I'm going to change that directory. Nvim test.c, do some boilerplate. Make a makefile. PCC. Test that out. Boom, our program runs. So now what I'm going to do is I'm going to make a struct. I'm going to call it thing. And it's going to have a weight and a type. Boom. And I'm going to open a file called thing.dat. Open it for writing to, and open it and make a new file if it doesn't exist. Store that, assign that to a file pointer. Fwrite. Then I'm going to make a new thing. Initialize some data. Boom. Need a comma, semicolon there. Write the data to a file at the size of the thing struct, one member, pass the file pointer, then do an f close. Boom. Get rid of that printf. Boom. We did it, and it didn't look like it did anything, but if we do a hex dump, the thing.dat file, hex dump, data, I'll call it data. We see that we get that raw data, and we do a little bit of changes here, and we get rid of this, do a thing, and we don't initialize it. Still open it up, but open up the file for reading instead. And then we're going to store the file into thing. Instead of doing fwrite, we're going to do an fread. And then we can print off the data. Whoops, printf. Wait. Thing.wait. And then we can do, what was it? Type. Thing.type. And we can actually read off our data. And we're reading it from that that thing.data file. So yeah. Now I want to get into some of the things you have to keep in mind when doing this. Notice how I allocated something on the stack, not the heap. That is a much simpler approach to doing this. If you allocate it on the heap, it would be harder to get the binary. It would be harder to write to the file, basically. So that's keep in mind when you're doing this is that you probably want to, in most cases, you're probably going to want to make sure that everything in the struct can be allocated on the stack instead of the heap. And you can do it on the heap, but it would be harder to work out, basically, is kind of what I'm saying. And you also want to think about alignments with structs and how, the size of the struct. So one thing to note is, so like if I made an int a and then like a char b, at least I know for my system that an a is 4 bytes and then a b is 1 byte, right? So, typically both these types together would be 5 bytes. But this struct total is not 5 bytes, it's 8. Well, why is it 8 bytes? I'll tell you what, it has to do with alignment. So with alignment, it's going to align, it's going to read every data as the same size chunk, right? And that size chunk is going to be the smallest data, I mean, the largest data type. In this case, the largest data type is 4, so that each chunk is going to be 4 bytes, right? Yeah. So what it does is this thing struct. So it wants it to be a multiple of the largest data type, right? So it says, okay, this is five bytes total, right? But 5 isn't a multiple of the largest data type, which is 4 bytes. So what is the smallest multiple of 4 that you can do with being able to store all this data? And that would be 8. So if I did a printf size of thing, we're gonna get 8 because of alignment. And you can actually disable struct packing and whatever and get rid of alignment. I don't remember how to do that precisely. See, I looked up the Drake meme. Yeah, I know. Because I was going to put it as a thumbnail for this video. See, no struct packing. What is it? This attribute, blah, blah, blah. So I'm going to copy this. This is something you could do if you wanted, but the thing to keep in mind about not having alignment is that it's not going to read the data. Alignment makes the data be read faster, and it does, it has other benefits, so it could kind of mess things up. So I think if we built this and ran it back, it's 5. So that doesn't do that alignment thing that I explained earlier now that we have the packed. And we could also do something like, if we know that we just only want this to be like a Boolean value, I could just do this, and now this is only going to be 1 bit. So I think this is probably still going to be 5 because it still has to be at least 1 byte. I don't know. This is kind of a curious thing that I'm going to see for myself too. 5. Yeah, it's still 5 because it has to at least be a byte. So yeah, that makes sense. But if I did another int, and instead of doing 4 bytes, I wonder if I could do 8 bits. I wonder if this will be for still 5. That is a curious 5. Yeah. So I basically made this int. It's still defined as an int, but it only is going to take up 1 byte now. Because this is this symbol is, it's what's called what is it called? Dev languages. See, I have everything very organized. Well, bit field. It's called a bit field. This is a bit field. So this is saying, okay, this is an int, and instead of taking what we're going to do 4 bytes, that's 8 times 4 bits. I only want you to do 8 bits, which is just 1 byte instead. So you can do that too if you want to, but you're just kind of changing data types at that point, and it has to be at least 1 byte big. So like if I did 9, I think it's going to be 4, 5, 6 bytes at this point now. Yeah. So it has to be still aligned to at least a byte. But yeah, that's, I think, all I wanted to show you.